Okay, let's continue on. Number 4 asks us to find the intervals for which each function is increasing, decreasing, and constant. So we want increasing, decreasing, and constant. Okay, so these are pretty easy to remember. Increasing is just when it's going up from left to right. Decreasing is where the graph is going down from left to right. And constant is where it's horizontal, where it's staying the same. Again, as you read it from left to right. There are a couple of ways that you can do it. I'm going to just go ahead and write down increasing, decreasing, and I'll do it 2 different ways, and constant. Now you can do it just by reading the graph, or you can do increasing and go from left to right, or you can do increasing, decreasing, and constant. It doesn't make any difference. Okay. If I look at this portion of the graph here, this is where it's constant. So it starts at negative infinity and goes up to -4. Okay. Always use parentheses. You may even want to put that up here. Always use parentheses. You don't include the endpoints. Okay. All right, so if I look from here to here, it is going up as you read it from left to right. So it is increasing between the x values of -4 and 0. Okay. Remember, you are looking for the values of x that this occurs. Well, then if you look at the next segment, it's decreasing, and it's still decreasing. So the values of x for which it is decreasing is from 0 to infinity. Now you can mark those if it's helpful for you, mark it on the x-axis. It is decreasing from here to here. It is increasing from here for my x values from here to here. And it is decreasing for my x values from here to here. Okay, so let's go ahead and do the same thing. Increasing, decreasing, and constant. And constant. Okay. Well, this one I did just by reading it from left to right. The way I'm going to do it this time is I'm going to find where it's increasing. Every place where it's increasing. So it's increasing from here to here, and of course that goes on forever. It's increasing from here to here, and it's increasing from here to here. So if I look at the values on my domain, this piece goes from -infinity to -8.5. And again, estimate. Here it is increasing. It looks like it's -3 to 3, so that's close enough. So I'm going to combine that with -3 to 3. And then here it is increasing for x values 8.5 to infinity. So now I'm going to look at where it is going down from left to right. So here and here. So from here to here and from here to here. So this here looks like it's going from -8.5 to 3, -3, excuse me, and then from here from 3 to 8.5. Remember, you are looking for the values of x for which this is occurring. And I wrote that down, so I'm going to go ahead and fill it in that it's none. Okay, number 5. Identify the location and values of any relative maxima or minima. Okay, so I'm going to do maxima in blue, minima in orange. Okay. And again, maxima is just a hill. So the maxima is when you have a hill, it's that point here. And minima is when you have a valley, and it's this point right here. Okay. So they're usually, oh, and I'm sorry, you can't see that. They're usually really easy to find. You have the maxima is the top of the hill. Okay. So there is a maximum of, let's see, that looks like 5.5, I guess. At x equals, and we'll call that negative 8.5. So this is the point, negative 8.5, 5.5. Well, let's see if there are any other maxima. So I've got one right here. That is the point 3, 3. So we have another maximum of 3 at x equals 3. So those are the tops of the hills. Now it looks like we've got 2 valleys on here. So this is the point negative 3, negative 1. So this is a minimum of negative 1 at x equals negative 3. And I forget to close my parentheses. And we have another one here. And let's see, that looks like it's 1.5 or 1.4. So we have a minimum of negative 1.4. I'll call it negative 1.4. So this is 8.5, negative 1.4 at x equals 8.5. Okay, same thing over here. All right, so let's see what I've got here. I'm just going to do these from left to right. All right, so here we have a minimum at negative 4, negative 3. So I have a minimum of negative 4 at x equals negative 3. I have a maximum 0, 5. So I have a maximum of 5 at x equals 0. And then I've got another minimum here at 3, negative 4. So I have a minimum of negative 4 at x equals 3. Of course, this tells it goes on forever and ever again. If you look at the whole graph, there is no absolute maximum. There is an absolute minimum, but these are relative, and notice it says relative. I forgot to write down the word relative in all of these, but if you just put it this way, that's fine. Okay, so this was kind of, I'll go ahead and switch videos again, and we'll get into, since we're changing topics.